Okay, I am in 8.1, day 7 CAMI assignment. We'll first start off with this solutions chart, which you've seen before. And this is going to be very, very helpful as you complete the systems vocab Google Forms. I will be referring back to this. We're going to be using this next week as well. Okay, so there are three types of solutions we can have with a system. The first type is we can have one solution. If there is one solution to the system, that means there is only one point, one XY ordered pair that satisfies the system. That is a solution to the system. And so what will these lines look like on the coordinate plane? They will be intersecting lines. Okay, they'll be lines that cross at one point. All right, so if there is only one ordered pair that works in both equations, that is one solution. Okay. So there's slopes. If there's one solution, their slopes will be different. Okay, now as you can see, if there's no solution, their slopes are the same. If there's infinitely many solutions, their slopes will be the same. So right away, if when you put the equations in slope-intercept form, if they have different slopes, you know right away there's one solution to the system. It doesn't even matter what their b's are, what their y-intercepts are. If they're different slopes, one solution. So in this system, for example, if you got y equals negative 2x minus 4 and y equals 4x plus 2, I can see the slope of this equation is negative 2. The slope of that equation is 4. They're different slopes, one solution. I know right away when I graph these, they will intersect at exactly one point. Okay, now the second type of solution we can have is no solution. All right, so if there's no solution, that means these lines will never intersect. They will be parallel lines like train tracks that will never cross. That means they have same slope and different y-intercept. Their slopes are the same. They have different y-intercepts. So for example, y equals 1 half x plus 1 and y equal 1 half x plus 2. Notice how their slopes are both 1 half. Their slopes are both 1 half, but their y-intercepts are different. This one's 1, this one's negative 2. So if they have same slope, different y-intercept, no solution. If they're parallel lines, no solution. If they never cross, no solution. All right, next, the third type of solution we can have is infinitely many solutions. If there's infinitely many solutions, that means these lines intersect at every single point on the line. That's why there's an infinite amount of solutions, because the line never ends in either direction. And so what do these lines look like on the coordinate plane? Well, they are identical lines. They are actually the same line on top of each other. And so if you're looking at a graph and you only see one line and it's asking you how many solutions there are, that's going to be infinitely many because both lines are on top of each other. And so because of that, they have same slope and same y-intercept. So if you're giving something like this, y equals 2x minus 1 and 2y equal 4x minus 2, if you take this equation right here and solve for y and put it in slope-intercept form, guess what you get? You get this right here. You get y equals 2x minus 1. And so they would have same slope, same y-intercept. They're the same exact line. They are identical and therefore infinitely many solutions. All right, here number 1 and 2, we're going to write the equation of the line and then tell what kind of slope the line has. Okay, now in number 1 here we have a horizontal line, a side-to-side line. And so if the line is side to side, if it's horizontal, the equation of the line is going to be y equals something. Okay, if it's a horizontal line, it'll be y equals whatever number it is on. The way to remember this, maybe this is helpful, is that this y right here is like an upside down H. It's an upside down H. And the word horizontal also begins with an H. Okay, so if you have a horizontal line, it's like an upside down Y right here, where the Y is an upside down H. It's Y equals whatever number this is on. This is on the number what? What number is that right there? That is negative 1, right? So the equation of the line is Y equals negative 1. That's the equation of the line. Now, what kind of slope does this have? We've already talked about how there's 4 kinds of slope. There's positive and negative. Positive if it goes uphill. Negative if the line goes downhill. There is zero slope, and there is undefined slope. So what kind of slope does a horizontal line have? in the horizontal line, we can make a z out of this. We can go like this, z. And z reminds us that there is 0 slope. Okay, so on right here, I can add text box and put 0 slope. A horizontal line has 0 slope. And number 2 here, we have a vertical line, an up and down line. And so the equation of this line is going to be x equals some number. X equals some number. And that number will be wherever the line is at. The line here is on that number. What number is that? 3. So x equals 3. That is the equation of the line. And if it was y equals, I gave you a hint because the y is an upside down h. In a vertical line, we have x equals because the top part of the x, if I circle this part right here, the top part of the x is a v. And the word vertical starts with a v. Okay? So if you see an up and down line, it's a vertical line. The top part of an x is a v for vertical. So x equals 3 is the equation of the line. What kind of slope does this have? Well, we've talked about how positive slope goes uphill, negative slope goes downhill. If it's a horizontal line, side to side line, it has 0 slope because we can make a z out of it. And if it's a vertical line, we can make this letter out of it. We can make an N for undefined slope. So undefined, U-N-D-E-F-I-N-E-D, undefined. Sometimes people call this no slope, and that would also be correct. N for no, okay? But we're going to go with undefined. Undefined. The second letter in undefined is an N. N, undefined. 0 slope for horizontal line, no slope or undefined slope for a vertical line. Number 3, we've done this before. We're going to identify the slope and the y-intercept, write the equation of the line, and then tell what kind of slope it has. Just by looking at the line, is the line going uphill or downhill? Looks to me like it's going downhill, and so we could say this has negative slope, right? So we would expect our m to be a negative number. Let's first identify b. Where does the line cross the y-axis? The y-axis is the up and down axis. It crosses right there. Right there is negative 2. So our B is negative 2. Okay. Now we're going to find some grid lines here. If I need to click the plus sign to zoom in to see more closely, I can. Okay. The B was right there, negative 2. Let's pick another point where it crosses the grid lines. How about right here? It crosses both grid lines there. So how do I get from this point to this point? Well, I'm going to rise how far? I'm not going to go up. I'm going to go down. I'm going to go down 1, 2. And if I go down 2, that's my top number. My rise is negative 2. I went down 2. After I went down 2, I go right 1. And so I ran 1. My rise is negative 2. My run's 1. What's negative 2 over 1? Negative 2 divided by 1 is negative 2, which makes sense because I just said my m, my slope, should be negative. Let me zoom back out here. So the equation of my line, remember I'm writing this line in slope-intercept form, which of course is y equals mx plus b. Okay, so I'm going to plug m in. Y equals m. What's m? M is negative 2. Then I have my x. Then b. What's b? B was negative 2. So this right here is the equation of the line in slope-intercept form. Y equals negative 2x minus 2. Y equals 2x minus 2. It has negative slope, which makes sense because my m right there is negative. Okay, number 4, this is an 8.1 day 7 part 2 video, so be sure you watch that one if you want to see that one worked out. Number 5 right here, solve the system by graphing. So remember, when graphing, I first need my equations and slope-intercept form. So let me call this equation 1, and let me call this one equation 2. It's very important to label which equation is which, or everything can get very messed up. Okay, you can confuse yourself if you don't label which one's equation 1 and which one's equation 2. So let's first solve equation 1. Let's put it in slope-intercept form. That way we can graph it. So here's equation 1, x minus 4y equal negative 4. I need to get y by itself, right? So we've practiced this before. We're using the same step to solve equations that we've always used since like August. So I'm going to move x to the other side by subtraction. So those x's are gone. This is a negative 4y. Bring the equal sign down. This term is a negative x. This term is a negative 4. And so I put the x term first and then the constant. Now I got to solve for y. So negative 4y means negative 4 times y. So I undo the multiplication by division. And so I divide not by 4, but by this term right here that is, or this number right here that's in front of y, which is a negative 4. And so that is what I divide every term in the equation by. Every term gets divided by negative 4. That way, these negative 4 simplify, and you have y equals. Now, right here, what number is in front of x? You should say an invisible 1, right? Or negative 1. All right, so what would this fraction be right here in front of the x? You got a negative 1 over a negative 4. So if you have a negative over a negative, that's a positive. And then you have the fraction 1 over 4, or 1/4. Okay, that is the number in front of this x. Don't forget to write your x. Okay, then you have this right here. You have a negative 4 over negative 4. What's negative 4 over negative 4? That is positive 1. So I put a plus 1. This right here is the equation in slope-intercept form. So m is 1/4 because that's the number in front of x. B is 1, right? Positive 1. So let's go ahead and graph that line. Then we'll come back and put equation 2 in slope-intercept form so that we can graph it. So equation 1, line 1 is begin with b. B is at 1, so I'm going to put a dot at 1 on the y-axis. Put a dot at 1. So here's the y-axis, dot at 1 right there. So I begin with b, then I move with m. Because m is 1/4, this tells me to go up 1, to the right 4, right? Up 1, right 4. Up 1, to the right 4. 1, 2, 3, 4. Okay, instead of going up 1, right 4, I can also change the direction and go down 1 and to the left 4. Down 1, left 4 from B. Let me try that. Down 1, left 4. 1, 2, 3, 4. And then make my line here. Okay, arrows on the end of the line. Arrows on the end of the line to show that it continues forever in both directions. Continues forever in both directions. And the end of the line, put a 1 and circle it. That is line 1 that comes from equation 1. Line 1 comes from equation 1. Okay, now equation number 2. Let's put it in slope-intercept form. So I got 5x minus 4y equal 12. Let's solve for y here. So move 5x to the other side by subtraction. Subtract 5x from both sides. So those 5x's are gone. I have a negative 4y that I bring down. Bring my equal sign down. My x term is negative, so I put negative 5x. This constant is positive, so I put plus 12. Okay, solve for y by dividing by not 4, but negative 4. Every term in the equation gets divided by negative 4 because I'm solving for y right here. These negative 4 simplify, so y equals. Okay, now remember, leave my fraction here as an improper fraction. This is negative 5 over negative 4. So I have a negative over a negative. That means it's going to be a positive. So positive 5 over 4. Leave it as improper. Do not make it a decimal. Don't forget to write your x term. So this is 5/4 x. Okay, then right here you have 12 over negative 4. What's 12 over negative 4? 12 over negative 4 would be negative 3. Okay, so this is my equation in slope-intercept form. That means m is 5/4 and b is negative 3. So if I'm going to graph this second equation, I begin with b. So b is at negative 3. B is at negative 3 right there. I begin with b and I move with m. Okay, since m is 5/4, this tells me to go what? Since my m is 5/4, this tells me to go up 5 and to the right 4. Up 5, right 4 from b. So let me go up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 to the right 4. 1, 2, 3, 4. Okay. I only need 2 dots here, so let me connect those. I'll go shapes, line, connect the line, arrows on the end of the line right here to show that the line continues forever in both directions. All right, so I've graphed line 1, graphed line 2. Let me put a 2 and circle it at the end of that line to show that's line 2. I've graphed line 1, I've graphed line 2. Now I need to see, where do they intersect? Where do they cross at? Well, they cross right here, right? That is the solution to the system. So what's its ordered pair right there? To get the ordered pair, I start at the origin. I would go right, 1, 2, 3, 4. So that's my x value. After I go right 4, I go up 1, 2. So right 4 up 2, that means the solution is 4, 2. 4, 2. Okay? Number 6, what is the x value in the solution of the system in the graph below? So the solution would be right here. So what's that ordered pair? I would go right 1. That means the x value is 1. Right 1 and up 1, 2, 3. Okay? So this is the solution, 1, 3, but the question is only asking me for the x value. So in this ordered pair, which one's the x value? Remember, x comes before y, just like the alphabet. And so this x value is a 1. So the x value in the solution is 1. Number 7, what is the solution to the system? Where do the lines intersect? They intersect right here. So what's its ordered pair? Start from the origin. You would go left 1, that's negative 1. Left 1, that's negative 1. And after you go left 1, you would go up 1, 2, 3. If you go up 3, that's positive 3. So your solution is negative 1, 3. Negative 1, 3. Number 8 is asking you about the y value. All right, so the solution would be right 1, up 3. So the solution is 1, 3, 1, 3. So which one's the y value? The second number, right? 3. Y value is 3 in the solution. What is the solution to this system? Where's the second line at? Well, it's on top of the first line, right? The lines are on top of each other. And if the lines are on top of each other, if they are identical lines, what does that tell you about how many solutions there are? Infinitely many, right? They are intersecting at every single point on the line. That means they have same slope and same y-intercept. So if they are identical lines, we can say that there's infinitely many solutions. So you can draw the sideways 8, or you can add text box, and you can say infinitely many solutions. Infinitely many solutions, because they're intersecting at every single point on the line. They are identical lines.